Hello, myself Professor H K Bhangale from Department of Electrical Engineering, SMD College of Engineering and Research Center, Evla. So I welcome all of you in a lecture series of Basic Electrical Engineering, First Year Engineering. So today we will discuss on alternating current. So let us continue with part 1 for alternating current. In that we will discuss how the alternating current is generated and also the various terms associated with the alternating current. So the alternating current is nothing but it is the supply which is used commercial and domestically purpose, that is the alternating current. The DC supply has a constant magnitude with respect to time, but here for the alternating supply or alternating current, the magnitude of the alternating quantity always changes with respect to time. In alternating waveform, there are two half cycles. One is positive and other is negative. And these two half cycles make one cycle, and current increases in magnitude in one particular direction and that attains maximum and starts decreasing, passing through zero, and it increases in opposite direction and behaves similarly. So how this can be generated, that now we will see. So here in figure, two magnets are we are watching, the North Pole and South Pole, right? So that these are the two pair of the permanent magnets, and in that pair of the permanent magnet, here the coil in a square shape, two coils are being placed on a shaft, or and that shaft is free to rotate, right? And that is nothing but the axis of rotation, and that axis of rotation, these two coils, coil AB and coil CD, are placed. Now the generators which makes the purely sinusoidal alternating voltage are called the alternator. And this figure itself shows the principle of alternator. The basic principle of an AC generation is the principle of electromagnetic induction. The sine wave is generated according to Faraday's law of electromagnetic induction. So whenever there is a relative motion between the conductors, this coil is a conductor. Whenever there is a relative motion between the conductor and the magnetic field, so here is the magnetic field. So magnetic fields of lines, flux of lines are generated from North Pole and will reach to the South Pole. And in between there is this conductor in the form of the coil is placed. Now these lines of flux are being cut by these conductors. So the velocity component which is responsible for cutting the magnetic flux and producing an EMF is a sine component, that is V sine of theta. So where theta is the angle measured in with respect to the plane of the flux. Now when the coil makes the angle of 0 degree, when the coil is make the angle of 0 degree, that time no flux line should be cut. Means this plane of this conductor is in the same direction as that of the lines of flux, and the EMF generated is can be given by this formula E is equal to PLV sine of theta. Where B is the magnetic field, L is the length, effective length of the coil, and V is the velocity of the coil, velocity of the rotation, you can say. Now, when theta is equal to 0 degree, that time no EMF will induce in this coil, and that time your E is equal to 0. But when this coil or this conductor makes an angle of 90 degree, that time my theta is equal to 90 degree, and that time I will get E, that is BLV, and that is the maximum value of the EMF that will be induced in this coil, and that EM is nothing but the maximum value can be given as BLV, and it gives the maximum value of induced EMF. So this induced EMF is the maximum value. So again, when this conductor rotates along the axis of the rotation, that time the angle of rotation changes from 0 degree to 360 degree, and when it completes the one complete rotation, that time one complete cycle will be generated. that corresponds to one complete cycle of the alternating quantity. So single turn alternator is shown in this figure. So the two conductors AB and CD are connected together at one end to form a single turn coil. The other ends of the conductor are connected to rings C1 and C2. So here the coil are connected at C1 and C2 along a slip rings through a resistance R. It completed and current will flows. The brushes P and Q are resting on the slip rings and they are stationary. The external resistance R is connected along with the stationary brushes. So when the coil is rotated, each conductor cuts the magnetic flux to induce EMF in it. The EMF induced depends on the position of the coil. Just I have told you, EMF induced in this coil is depend on the position of the coil in these magnetic lines of flux. So if it is 0 degree, I am making an angle of 0 degree, no EMF will induce. If it makes an angle of 90 degree, maximum EMF will induce. So likewise, depending on the position, the magnitude of the EMF induced in that will be changes, and it behaves as a sinusoidal behavior. The EMF drives the current through resistance R. Thus, if theta is the angle between velocity component with respect to the plane of the flux, then as theta varies from 0 to 360 degree, the EMF in the conductor varies an alternating manner, that is from 0 increases to achieve maximum in one direction, that is in positive direction, means positive half cycle we will get, and again if increases the angle in a third quadrant, then it increases in a negative direction, that is it compresses the negative half cycle of an alternating components. So this variation of EMF in a conductor is graphically represented by purely sinusoidal waveform. So when such alternating EMF is used to supply an electrical load, then the resulting current waveform is also called as alternating, and that is the purely sinusoidal in nature. So in this way, a sinusoidal waveform can be generated using this set of alternators. So next is the different forms of EMF equations. Now, as we have just said that the EMF induced in a coil, that is E is equal to BLV sine of theta. So that BLV is nothing but the maximum EMF induced. So that equation is correspond to the alternating equations, alternating current equation or voltage equation, where that EM is nothing but BLV. So BLV I have replaced here. E is equal to BLV sine of theta. This BLV is nothing but my EM. So E is equal to EM sine of theta, and theta is equal to omega t in the radian. Hence, this equation of alternating quantity becomes E is equal to EM sine of omega t, or otherwise it can be written as E is equal to EM sine of theta. Now, where omega is nothing but your angular frequency, and this angular frequency is nothing but the electrical radiance per unit second, right? So omega can be given as 2 pi f. So I can replace this omega t by 2 pi f, and this equation now becomes E is equal to Em sine of 2 pi ft. Also, f is nothing but my frequency, and it can be given as 1 upon t, that is the reciprocal of the time period. So this equation again can be represented like this: E is equal to Em sine of 2 pi upon t into t. So in this way, there in the different ways I can represent the EMF equation of an alternating quantity, that is E is equal to Em sine of theta, or E is equal to Em sine of omega t, or E is equal to Em sine of 2 pi ft, or E is equal to Em sine of 2 pi by t. So like this, these equations can be represented. So here the point you should be remember is that the mode of the calculator, whenever you will calculate the different quantities related to this equation, that time the mode of the calculator should be converted to radians to calculate the sine of the angle expressed in radians before substituting in any of the above equation. So you remember this point. Again, if this is for the equation for the voltage or EMF induced in the coil, and this can be represented in such a different form. Now, instead of the EMF or voltage, if current is there, then in the same way, the current equation can be represented in the different form, that is I is equal to Im sin of theta, theta is equal to omega t. So I is equal to Im sin of omega t, omega is equal to 2 pi f, hence I is equal to Im sin of 2 pi f t. So this can also be represented as f is equal to 1 upon t, that is I is equal to Im sin of 2 pi t upon t. So in this way, the equations can be represented in different and different ways, either voltage or current. And this small v and small I that represents instantaneous values. Small I and small v represent the instantaneous values of current and voltage respectively, where Im and Vm or Em that represent the maximum value. That is the maximum value Im or Vm. Now here the sine values at different angles. So if the angle is 0 degree, then what is the sine of 0? It is 0. Angle is 15 degree, then it is 0.25. Angle is 30 degree, then sine 30 is equal to 0.5. That is half. So likewise, for a different and different angle, that is for one complete rotation, okay, from 0 to 180, it is positive half cycle, and you will get the angle from 0 to, it increases in anti-clockwise direction in positive direction. So it from 0 to 0 means positive and half cycle completed. Then after that negative half cycle will start from 180 degree to 360 degree, and that time it increases in negative direction, means it is a negative half cycle. So in this way, when the angle or when it rotates from 0 to 180 degree, positive half cycle complete. Again next from 180 to 360 complete negative half cycle. So for complete rotation from 0 to 360, it corresponds to one complete cycle. So this is that cycle, sinusoidal alternating current. So it is positive half cycle, it is negative half cycle, again positive half cycle. So from 0 to 180 degree, the values will be varies from 0 to maximum value in positive, again it reduces to 0. Again for negative values from 180 degree to 360 degree, it increases in negative direction. Here negative peak you will get maximum value, again it reduces to 0. So likewise, this one cycle completed and next cycle again start. So such a cycles of alternating current will continue and it rotates from 0 to 360 degree. So here the different types of these waveforms are shown. It is a square waveform. It is one cycle of the square waveform. It is triangular waveform. So and here is a sawtooth waveform. So these are also the alternating types of waveforms. So here sinusoidal alternating current. So it is positive half cycle. It is negative half cycle. Okay. So it varies in this way and completes it cycle. So it is a sine wave. So here is an example, right? The four ways of representing an alternating current voltage given by a magnitude of 5 volt and frequency of 50 hertz. So you have to solve this. So given is the write the four ways of representing AC voltage. So in different four forms, equations, you have to represent the this alternating current and voltage given by this magnitude is 5 volt. Magnitude is 5 volt means EM maximum value is 5 volt and frequency is given F is equal to 50 hertz. So F is equal to 50 hertz means omega is equal to 2 pi F. Hence it is 100 pi radian per second, and T is equal to reciprocal of frequency, that is 1 upon F is 1 upon 50 second. So the voltage can be represented as E is equal to Em sin of theta or E is equal to Em sin of omega t. Omega is nothing but your 100 pi. Hence it is E is equal to 5 sin of 100 pi t. Similarly, E is equal to Em sin of theta and 5 sin of theta volts. E is equal to Em sin of 2 pi ft. So 5 sin of 100 pi t. Okay, then E is equal to Em sin of 2 pi t by t. So it can be represented in this way: 1 upon t is equal to 1 upon 50. In this way, we can represent the given alternating voltage in four different ways. Similarly, here the next example is there. An alternating current of frequency 60 hertz has a maximum value of 12 ampere. So its Im current value is given. Im is 12 ampere. So write down the equation for instantaneous value. I, small I equation we have to write. I Im sin of omega t. omega is not given directly. Here frequency is given. So omega is equal to 2 pi f. So omega is equal to 2 pi f. It gives 2 pi f. F is equal to 60 hertz, which is 377 radian per second. So equation of instantaneous value can be written as I enough sine of omega t, that becomes I into I is 12 and omega t is 377 t. So in this way you can represent it. And next t is equal to reciprocal of the frequency. So it is 1 upon 360. Okay, second, sorry, it is time given. Okay, so I is equal to 12 sine of 377 upon 1 upon t, that is 360. It is 12 sine of 1.072. And if you find out the answer, then it is 10.3924 ampere. So in this way, you can solve this such a types of problems. For that, you should know the different forms of the alternating equations, either of current or voltages. So this is the next part of I is equal to 9.6 ampere is given. So sine of 1.047 must be calculated radian mode. Okay, after that you will get I 9.6 ampere. So 9.6 is equal to 12 sine of 377 t, where sine of 377 t is equal to 0.8. So what is 377 t? It is sine inverse of 0.8. So after taking the inverse, you will get t is equal to 2.459 into 10 to the power minus 3 second, or 2.459 millisecond will be your answer. So thank you. This is all about the generation and the different forms of the alternating equations. You go through it. In part 2, we will discuss the next topic related to sinusoidal waveforms. Thank you.